Hi guys, it's me again, Randolph Budu, and today we are going to do a mathematics lesson. So like I said last time, it's a bit different. You are in your home and I'm across here, but let's make it meaningful. Put down the tablet, put down the phone, get some kind of writing equipment, a piece of paper, a pencil, and let's see how best we can learn together during this time. So today we're going to start with a story. The story is about a cartoon fella named Tim. Now I want you to listen to this story carefully so by the end of this lesson you don't ever end up like Tim. So Tim was walking home, and on his way home he came across a bunch of numbers on the ground written, and he didn't know how to interpret it. He started to think, what does this mean? What do all these numbers say? So Tim went on thinking, and for himself, he said, okay, maybe I need to start from the right-hand side and call those numbers. So Tim started. The number is 1987, and he got confused. Maybe he should start from the left-hand side. And he said, okay, this number is 1357. But again, that didn't make sense. Why would someone write numbers next to each other just like that? So Tim was above everything confused. But you take a second. Can you call the number that you're seeing on the screen? Can you make out where Tim went wrong? You tell me. If there's someone next to you, you tell them. Where did Tim go wrong? What was he doing wrong? And most importantly now, what helped you to be able to read this number well? If you said place value, then you're correct. Place value is what we're going to be talking about today. And what does place value mean? Place value means that according to where a digit is placed, it has a different value. So let's look at some of the numbers coming up on your screen now. We have 42, 4, and 425. If you would look carefully, the digit 4 in each number is being encircled. Is there a difference between each digit? Yes, there is. But what makes the difference in each digit? That's correct. It's according to where that digit is placed. So the first 4 has the value of 40. The second 4 has the value of 4. And the third 4 has the value of 400. Now I know all of you are bright students, but today's lesson is catered for a standard 4 class. And definitely if you have a brother or sister in standard 5, they are more than welcome to sit down and listen with you. Today we try to cover 3 different things. First, we're going to learn and review all about our number system. Secondly, we're going to recall number families, and you'll see what this means a little later on. And thirdly, we're going to name numbers, including numbers with decimal fractions. So are you guys ready? Are you focused? This is review for some of you all. It may be new content for others, but the most important thing that must happen here today as I move forward is that learning must take place. Something must happen in your mind to move you from where you are to a deeper state of learning. So let's get excited. Place value. Place value is based on our number system. And our number system is based on something called a concept. Have you ever heard the word concept before? If you haven't, let's think about it. Concept has a meaning. A concept is, look, there's a hint. What do you think a concept is? What synonym can you find for the word concept? You may have had a different idea, but this is my idea. Concept means idea. The both words are synonyms. They mean the same. So what is the concept that our number system is based on? That concept is 10. In the sense that when we have 10 of any one value in our number system, we get a different value. Think about that. You would have heard about the ones value column. Can you write 10 in that column? What about the tens value column? Can you write 10 in that column? So I'll say it again before I move on. Our number system is based on the concept of 10. Whenever we have 10 of one value, we get a new value. Let's see how. So we have a simple place value chart that you would have interacted from within standard 2 and standard 3. In that place value chart in the ones column, we could have the number 1, 2, 3, 4, 5, 6, 7, 8, 9. All those are fine. But look on your screen. Is that okay? Can we have the number 10 in the ones column? No. Why is that? What happens? What do you remember happens when this situation occurs? So 10 in the ones column is wrong. But essentially, when we have 10 ones or 10 of any value in our number system, we get a new value. In this case, that value is 110 and 0 ones. You all saw it? Let's look at it again. The 10 in the ones column is wrong. But when we have 10 ones, we get 110 with 0 ones. Similarly, it's okay for us to have 110 because that's our new value. It's also okay for us to have 2, 3, 4, 5, 6, 7, 8, even 9 tens in our tens column. But is this okay? No. 10 in the tens column is wrong. Because again, let's remember the concept of our number system. Our number system is based on the concept of 10. So therefore, if we have 10 tens, what new value do we get? That's correct, 100. Now let's think a little further. If we have 10 hundreds, what new value do you get? 1,000. If you have 10 thousands, what new value could you get? And this goes on forever. In maths, it goes on infinitely. And we will see more of that as we go along. So for place value, a simple way to think about it is families. In our place value chart, there are different families, but each family has something similar. And it's that each of the families are made up of 3 members. How many members make up each family? Good, 3 members. So let's look. In the place value chart, the smallest and the most important, not the smallest, the most important member of all the families of the entire place value chart is this fella right here. And he is ones. When we get, remember, when we get 10 ones, what new value is created on the place value chart? Tens. Good. When we get 10 tens, what place value member is created on the place value chart? Hundreds. So every family has 3 members, a ones member, a tens member, and a hundreds member. Let's say that again. Every family has 3 members, a ones member, a tens member, and a hundreds member. And guess what? The name of the family always takes what the ones place is. So this family on your screen is called the ones family. So what do you think is our next family on our place value chart if we go to the left? Yes, it's a thousands family. So who is the ones member of the thousands family if we say that the ones member always takes the name of the family? I'm giving you a second to think. So good. The ones member in this family is named thousands. The tens member is named tens of thousands. The hundreds member is named hundreds of thousands. Do you all see a pattern? I'll give you a chance to think. And in thinking about that, tell me also, what do you think is the next family in our place value chart if we continue to the left. And that is the millions family. Who is the ones member in the millions family? It's millions. It takes the name of the family. And then we have tens of million, who is the tens member, and hundreds of millions, who is the hundreds member of that family. And remember what I said earlier, this place value chart can continue infinitely without ever stopping if we continue going to the right. All you must remember is that each family has 3 members, a ones member, a tens member, and a hundreds member. So what would be the next family after millions? If you said billions, that's correct. And billions would have a ones member, billions, a tens member, tens of billions, a hundreds member, hundreds of billions. And we can go on forever once you know that pattern. But for your sake, you just need to know only up to the ones member in the millions family. Aren't you lucky? But you, with your brain and your ability to think, you can go much further if you want. You would have heard me talking about going to the left and the fact that this place value chart can grow infinitely bigger as we go to the left. What you must also know now, because you're bright enough at this point in time, is that this place value chart can also go infinitely to the right. The only difference is that the numbers get smaller. So much so that all the numbers to the right are smaller than 1. Now this is review. So you tell me, and if you know and there's somebody next to you, tell them also. There is something very, very important that we must use so that we can carry our place value chart to the right. So like I said, we can go and get bigger as much as we want to the left. We get smaller when we go to the right. What makes the difference? What makes the difference is this. Do you remember the name? Look at it. Think about it. What is the name? If you said decimal point, then you are correct. So for those of you who don't understand yet, that's okay. Let's speak it through again. As we go to the left and look at the left arrow that has the word bigger, our numbers and our number families get infinitely bigger. Forever they get bigger and bigger. But we put that point on the right of the ones value, and that point allows us to write numbers or decimal fractions that are smaller than 1. And this can go on also infinitely forever when we extend our place value chart to the right. Let's look at the name of these family members. So a place value chart with a decimal point. We start with the ones, and then we have a decimal point. And after the decimal point, just for you to understand and for you to learn at this level, there are 2 members, a tenths member and a hundredths member. Look at those 2 words closely. What is different in those words as opposed to tens and hundreds? How are they spelled differently? And when you figure out how they are spelled differently, then tell me, how are they pronounced differently? Make sure and tell your brother or your sister who is next to you. You can be a teacher at home also. So good. After the decimal point, as we go right, we have 2 smaller values. Firstly, the tenths value that ends with a T, H, and a S. And emphasize that when you say it, tenths. And we have a hundredths value with, again, a T, an H, and an S at the end. Emphasize as you pronounce it, hundredths. And they allow us to write decimal fractions, numbers that are smaller than 1. So we have the decimal points. The first value after the decimal point as we go right, tenths. And then the second value after the decimal point as we go right, hundreds. So let's look at an example of an entire place value chart up to hundreds of thousands and up to hundreds. Look at it. Everything that we just spoke about, talk it through in your mind, point at the TV screen if you need to, ask yourself a question, maybe even say, yes, this is what Sir was talking about. I understand now. You have 5 seconds to do so. Make sure that you can see where everything should be in the place value chart. So now we're going to take an example and we're going to spend some time learning how to say numbers that have decimal fractions in them. So I want to tell you what is the wrong thing to say. And I want you to listen well. You never, ever, ever look at the number on the screen and say 0.7. No. Never, ever. If you ever hear somebody say 0.7, let an alarm go off in your brain, let red signals and lights flash, and you know automatically that is wrong. The way to read this number, children, is by saying 7/10. Look at it and say that for me, please. This is not 0.7. This number is 7/10. Good. Now, when we are writing decimals, we always use the name of the smallest value. So look at the second number on your screen. Now you're very attracted to say 0.07, but again, anytime you hear a decimal being called with 0 point something, let red lights flash and alarm go off in your head. It's wrong. If I said that we use the smallest value when decimals are present, then what will we call this number? Look at it. We have no ones value, we have no tenths value. But we do have a hundredths value. What is the name? That is correct. The name is 7/100. What is the name? Say it again. The name of this number is 7/100. Let's look at another number. So in this number now, we have no ones value. The ones value is 0. That holds the place. We have 6 as the tenths value and 7 as the hundredths value. Remember, I said when calling the names of decimals, we use the smallest value. So tell me, what do you think is the name of this number? That's correct. This is not 0.67, rather it's 67/100. What is that? I didn't hear you. Thank you. It's 67/100. What about this number now? In this number, our ones value is not 0. Our ones value is 5. So, do we abandon what we have learned? Do we run and say 5.67? No. Look at it. It's the same 67/100, but now we have a 5 in the ones column. So how do we say it? We say 5 and 67/100. Say that number for me, please. Let me hear you one more time. Good. That number is 5 and 67/100. We have another number now. And I know you've gotten enough practice, so you're ready to tackle this one and say it correct, not even the second time, but right away on the first time. So you tackle this number. We start from the thousands family. We name the 3 numbers. Then we go to the ones family. We name the 3 numbers. And then we go to the decimals and we name the 2 numbers. At no point are you supposed to use the word point. So take a grab at it. I'll help you. I'll start you off. 364,536 Now finish it off for me. And, not point, and 67 hundredths. Excellent. Let's see it all together now. 364,536 and 67 hundredths. Remember that TH. Now you say it by yourself. Make sure you understand how the words should flow out of your mouth. That's good. One last time. 364,536 and 67 hundredths. Make sure and put in that and there, right before you always name the last family. So let's start to take some challenges. We must understand something else about our number system. So I know about our numbers, So I know you understand decimals. But let's talk about the values that different places take. So take, for instance, 345 on the screen. What is the tens value? Think about it very quickly. The tens value is 40. Good. We have 4 in the tens column, which gives us a value of 40. But let me ask you a question now. How many tens are there in 345? Now this is where thinking has to happen. You heard the question, don't just blurt out an answer. The question wasn't what is the tens value. The question was how many tens are there in the number 345? Where your thinking must go is like this. We learned that our number system is based on the concept of 10. So in 100, what do we have? How did we form that 100? What did we get 10 of? Yes, we got 10 tens to give us 100. So therefore, you should know, and if you don't know now, you do, that in hundreds, there are tens. So if I ask you about the number 345, then you are supposed to look at the tens value and everything going left of there to know how many tens there are. So in 100, there are 10 tens. How many tens are there in 300s? That's easy multiplication. 3 by 10, which gives us 30. But we also had tens in the tens column. How many do we have? 4. So 30 plus 4 is how much? 34. So in the number 345, how many tens are there? Good, there are 34 tens. Let's look at this number now. Read the number firstly for me, and then I will tell you. That number is 3,456. Now it's a similar number to the one before. We have some similar digits. If I am to ask you how many tens are there in that number, what would you consider? Don't give me the answer. Let's understand the process to get the answer. What would you consider? We would consider the fact that the tens column has tens in it. The hundreds column has tens in it. And the thousands column has tens in it. The only column that doesn't have tens in it is the ones column. So therefore, how many tens do we have in the number 3,456? We have 345 tens. Because we have 5 tens in the tens column, 40 tens in the hundreds column, and in the thousands column, we have 300 tens. Because if there are 10 tens in 100, and there are 10 hundreds in 1,000, it means that there are tens in both. And you multiply it and we get 100 tens in 1,000. So there are 345 tens in this number. How many ones are there in this number? The thinking is simple again. Ask yourself, what numbers contains ones to make them up? The ones value contains ones, the tens value contains ones, the hundreds value, as well as the thousands value. So this one is the simplest. There are 3,456 ones in this number. Let's look at the third number, 67,785. I'm challenging you now, and I'm making it easy. There is a tens of thousands value in this number, but my question is, how many thousands are there in this number? When you're thinking, ask yourself, what values are made up or contain thousands? We start with the value itself, which is thousands, and you go to the left. So the thousands value is 7. There are 7 thousands there. But the tens of thousands value is 6. And that's 6 by 10 thousands for each tens of thousands. That's a bit wordy. But it's 6 by 10, 60, plus 7. We have 67 thousands in that number. What's the next number on screen now? Say it for me. 356,780. Give me some quick answers. What is the hundreds of thousands value? 3. What is the tens value? 80. Now, I was testing you. If you said 3 for that hundreds of thousands value, is that correct? I didn't ask you what is the digit, I asked you what is the value. Understand the difference. Is it 3? No, it's 300,000. That's the value. Good. Now I'm asking you now, how many tens of thousands do we have in that number? You start from the tens of thousands and you go to the left. A simple way is you block off everything that's irrelevant and call the number that remains. So the answer is 35 tens of thousands. And our last number now, read that number for me. 1,056,890. My question is, how many hundreds of thousands do we have in that number? We have 0 in the hundreds of thousands column. But does that mean we have no hundreds of thousands? Think, what do we use 10 of to make up 1 million? We use hundreds of thousands. So in 1,056,890, we have 10 hundreds of thousands. We have another number there. Call that number for me. 8,088,973. Just tell me, what is the hundreds value in that number? Did you say 9? If you did, you're wrong. And we have to think a little bit. What is the value, not what is the digit? The value is 900. So I think that's enough for today, guys. And we're going to wrap up. And I hope that you would have learned something. Let's go back through some of the points that we learned. Our number system is based on the concept of 10. Families within the place value chart are each made up of 3 members. A ones member, a tens member, and a hundreds member. Our place value chart can extend both to the right and the left. When we go to the left, we get infinitely bigger. When we go to the right, we insert a decimal point and we get infinitely smaller. Decimals are never referred to as point something. Rather, we use the place values to name them. So I will never say 0.7 when I have a 0, a point, and a 7. Rather, I would say 7 tenths. So this is the start. We're starting back from place value, but we're going to go forward in learning. So see you soon right here. Make sure you have your book. Make sure you have your pencil. Definitely exercise your brain and let's get to learning. Thank you, guys. Take care.